Good day, students. So today our topic is about wave, carrier of energy. Waves are all around us. You can cook some of your food in microwave, listen to your favorite music over the radio through sound waves, and enjoy swimming in sea water waves or even wave your hands to say hi and goodbye to someone whom you know. This lesson will focus particularly in the nature of the kind of wave that transfers energy such as sound and light. This will also deal on the common characteristics and main differences of various types of waves and show how they are essential in the transmission of energy. So our objectives for this presentation. At the end of this presentation, students should be able to know the following. 1. The nature of waves. 2. Types of waves. 3. Parts of waves. And 4. Characteristics of wave. Okay, the nature of waves. The light coming from the sun, the sound produced when someone strikes a drum, the sea pounding on the shore, and the transmission of a television program. What do these things have in common? They are examples of energy being propagated by waves. Although waves are invisible, they play a very important role in this physical world. But what is wave? Wave is a disturbance that travels through a medium from one place to another. The wave moves the particles carrying the energy. So when the wave passes, the particles are moved or displaced from the rest position but return to where they are when the wave has passed. The movement of the wave depends on the particles of the medium through which it travels. The medium which carries the wave can be solid, liquid, or gas. For example, when you throw a stone in a pond, the water is disturbed, causing it to move up and down. The ripples that you see are due to the passing wave carrying the energy. So when the waves carrying the energy have passed, the water will stand still. Different types of waves have different characteristics, which can be used to distinguish one from the other. Waves can be categorized based on the orientation of particle motion as wave carrying energy passes and on the type of matter they are able to pass through. So let's move on to the types of waves. There are two types of waves. A, longitudinal and transverse, and letter B, mechanical wave and electromagnetic wave. Let's first discuss the longitudinal and transverse waves. Longitudinal waves. In this category of waves, particles of the medium are moved back and forth parallel to the direction of the motion of energy. Example of this is the sound wave. While transverse wave, this wave category, particles of the medium are moved perpendicular to the direction of the motion of energy. Examples are water waves and electromagnetic waves. This is the illustration of longitudinal wave and transverse wave. Next is the mechanical wave and electromagnetic wave. Mechanical wave, a type of wave that needs a medium to travel. Medium can be solid, liquid, or gas. In the absence of a medium such as in a vacuum, this wave cannot pass through. An example of mechanical wave is sound. You cannot hear anything in the outer space because there is no medium to transport the sound. Next, electromagnetic wave. Magnetic wave is a type of wave that does not need any medium to propagate. It can therefore pass even through a vacuum. The best example of this is the light coming from the sun. It reaches the earth because even if the outer space is empty like a vacuum. Let's move on to the parts of a wave. So the parts of a wave depends on its type. There are crest and through. So the crest is the highest part of a transverse wave here. And through is the lowest part of a transverse wave. Next is characteristics of wave. A, wavelength, and B, amplitude, and C, frequency. So wavelength refers to the length of one complete wave. So this is the wavelength. It can be from crest to crest and through to through. This is symbolized by the Greek letter lambda. Next, amplitude. Amplitude refers to the height of the wave. So this is the height of the wave, which is called amplitude. And frequency refers to the number of waves passing through a point per second. The unit of frequency is hertz. The shorter the wavelength, the higher the frequency, and the longer the wavelength, the lower the frequency. So this is the frequency. It's just the number of waves passing through a point per second. So that's it. That is that ends our presentation about wave. I hope you have learned something new today and see you on my next vlog. Bye.